afternoon, everyone. My name is Shivam Sharma, student of MTech second year from Delhi Technological University. The topic of my research is comparative study on the effect of filler wire on TIG welded joint of aluminum alloy using Taguchi method. So first of all, I would like to give a brief idea of aluminum alloy. What is aluminum alloy? So as we know, in modern industrial applications like automobile manufacturing, shipbuilding and aircraft construction, aluminum alloys are widely used because of their excellent properties like high corrosion resistance, high strength to weight ratio, high ductility and recyclability. These aluminum alloys can be classified into various series from 1000 series to 8000 series, but only 6000 series are very popular in fabrication industries because of their good strength and high weldability and high ductility. So these 6000 series of aluminum alloy can be classified into further categories like 6061, 6063 and 6082. But our research focuses on aluminum alloy 6082 because this 6082 aluminum alloy has replaced the other series of aluminum alloys in various applications because of its high strength. So to meet this demand, welding can be done. So basically the welding of aluminum is different from the welding of steel and other metals because there is a formation of oxide layer in aluminum alloy, and there is also a tendency of hot cracking. So we need to take care of the process parameters to form a sound welded joints. Generally welding can be done by various processes like gas tungsten arc welding, gas metal arc welding, resistance welding, laser beam welding and electron beam welding. But in our study, we have used the GTAW welding because various researchers suggested that the joint formed by the GTAW welding is having good strength and it is relatively less expensive process. So I have gone through various research papers. I will discuss about them in very brief. So Adamowski studied that aluminum alloy has replaced steels in various applications. Monsagnia studied that addition of manganese to 5356, there is an effectively reduction in the recrystallization so that we can getting a good welded joint. Daniel Das et al. Employed two different filler wires, 4043 and 4047, and he found the better properties with ER4043. So on the basis of these literature reviews, we have found research gap. Some of them are that although GTAW is very popular process for aluminum welding, but still there is a significant challenge to weld aluminum defect-free. Next thing is that considerable work has been done on other grades like 6061 and 6063, but very limited work has been done on aluminum alloy 6082 because it is relatively a new aluminum alloy. And ideas to improve wettability is also missing by the use of other filler materials. So why we have chosen, basically in brief, what I'm trying to say that what I'm doing, I am just trying to weld the aluminum alloy with different filler materials because aluminum can't weld without the filler materials because there is a tendency of hot cracking in aluminum alloy. So the objectives of work is to optimize the different welding parameters with the help of Taguchi method, and characterization of welding joint has been done. So this is our experimental methodology on which selection of materials. So we have chosen base material as a 6082 aluminum alloy. It is basically a silicon and manganese rich aluminum alloy, and it is having the highest strength. And it is used in applications like trucks, bridges, cranes, barrels, etc. And we have used the two different filler materials, ER4043. It is basically a silicon rich filler material. Due to high content of silicon, there is a sudden increase in wettability of liquid metal in the weld bead, so that we are able to get the good joint. Next is ER5356. It is basically a magnesium rich aluminum alloy, and it provides high shear strength in the welded joint. So we have selected the aluminum alloy sheet of 3 mm thickness and cut it down into 120 by 70 mm dimension with the help of shearing machine. So next is selection of process parameters and optimization. So on the basis of research papers, we have selected the three process parameters. These are current, welding rod diameter, and gas flow rate. The operating range of these parameters selected on the basis of on the basis of the appearance of weld bead and the depth of penetration. Various numbers of experiments has been carried out by varying the one process parameter and changing the other process parameters. To optimize the process parameters, Taguchi L4 orthogonal array has been used with 3 factors and 2 levels, as we can show here. Why we have used Taguchi method? Because Taguchi method help us to reduce the number of experiments. Basically, it provides us a predictive model to optimize the solution. So basically, these are the our 4 levels of this table. On the basis of this table, we have prepared welded joints. We can see here, these are our welded joints. This is the weld specimen with ER4043 filler wire, and this is the weld specimen with ER5356 filler wire. GTAW welding has been taken, and argon was used as a shielding gas, and welding was done in a single pass. So next thing is characterization of welded joint. So why we have performed tensile test? Because with the help of tensile test, we are able to get about the nature of weld specimen under the tensile loading. For this, ASTM E8M standard has been followed, and the laser cutting technique is used to cut the specimens. These are the, just a minute. This is the tensile test specimens of weld specimen with ER4043 filler wire, and this is the tensile test specimen with ER5356. This is the universal testing machine of 50 kilonewton capacity present in DTU used for tensile testing. So next analysis is micro hardness analysis. So micro hardness test analysis has been done on the optimized sample via Vickers hardness testing machine, which is having weight of 500 gram, and indentation time was kept at 10 seconds. Basically, 3 values are recorded from each zone. 3 values are recorded from heat affected zone, 3 values are recorded from weld bead, and 3 values are recorded from the parent metal. And the graph has been plotted between hardness value and the center from the distance. This is the Diamond 40 Stuart's micro hardness testing machine. Next analysis is residual stress analysis. So first I would like to tell something about residual stresses. Basically, these are the stresses present in the specimen when there is no external loading. Why there is importance of analysis of residual stress? Because residual stresses governs the fatigue life, distortion, corrosion resistance, and dimensional stability of welded specimen. That is why we have performed the residual stresses. So non-destructive X-ray diffraction technique is used to analyze the residual stress of optimized weld sample. This is the pulsatic micro 360 and X-ray diffraction machine used for the testing. So next thing is results and discussion. So basically, we have used the Minitab software for design of experiments to perform the Taguchi analysis, and we have chosen the larger SN ratio characteristic. Because why we have chosen larger SN ratio characteristic? Because we want to maximize the ultimate tensile strength. So we have plotted this. Plotted this SN ratio curve with the help of Minitab software, and we are getting the optimized process parameters for the maximum tensile strength with ER4043. Here we can see that we are getting for maximum tensile strength of weld specimen with ER4043. We are getting the level of current at 170 ampere, level of filler rod is 2.4 mm, and level of gas flow rate is 10 millimeter. And we are getting maximum ultimate tensile strength for weld specimen with filler wire 4043 is 158 megapascal. This is the optimization of process parameter for weld specimen with filler wire 5356. Here we have performed the same thing. Here we are getting the optimized process parameter at current at 170 ampere, filler rod at 2.4 mm, and gas flow rate at 10 mm. But here we are getting tensile strength 187 megapascal, which is more in comparison to filler wire 5356. So next analysis is tensile test analysis. So as I have discussed in the previous slides, that we are getting tensile strength of 187 megapascal with ER5356 and 158 megapascal with ER4043. These are the pictures of fractured weld specimen after the tensile strength. So, and this is the stress strain curve for the fractured weld specimen with ER5356 and ER4043. Here we can say that we are getting maximum strength with ER5356, and yielding takes place in ER5356. As we can see in the graph, that there is a sudden failure with ER4043. So we can see that we are getting good strength with filler material 5356. Next analysis is micro hardness analysis. So we have plotted as I have discussed earlier, we have plotted the graph between micro hardness and the distance from the center. And this red color line shows the hardness values of weld specimen with filler wire 5356, and pink line shows the hardness values with filler wire 534043. And we are getting the highest hardness value of 108.41 with the ER5356. As we can see from the graph that we are getting more value of hardness with filler wire 5356. Next analysis is residual stress analysis. So we have performed the residual stress analysis on the optimized weld specimen of both filler wires. So as we can see in the table, this is the weld specimen with filler wire 5356, and these are the levels at which the optimized value comes out. So we have performed the residual stress analysis on the weld bead and at the parent metal. As per the various researchers, that they suggested that the tensile nature of residual stress exists at weld bead, and compressive nature of residual stress exists at parent metal. Basically, here plus indicates tensile residual stress and minus indicates compressive residual stresses. So our results also match with the suggestions of researchers that we are getting tensile nature of residual stresses at the weld bead and the compressive nature of residual stresses at the parent metal. Also, we conclude one thing from the table, that we are getting less value of residual stress when we have used the ER5356. That might be the reason that ER5356 has the highest has more strength than the weld specimen of four of with filler wire ER4043. So now comes to the conclusion part. We have successfully optimized the process parameters of weld specimen with filler wire 4043 and 5356 with the help of Taguchi method. For the optimum level of process parameters for maximum tensile strength for A6082 is comes out to be 170 ampere of current, 2.4 mm diameter of filler rod, and 10 liter per minute of gas flow rate. This can be explained that when we increase the value of current, there is a deep penetration of oxide layer, and the liquid metal can go up to the root of the weld specimen and go to every corner, so that we are getting the good strength. Next thing is that tensile strength of weld specimen with 5356 is 187 megapascal, which is more than the weld specimen with filler wire ER4043, which is having strength of 158 megapascal. We are also getting high hardness value with filler wire 5356. Next thing is that tensile residual stress exists at weld bead and compressive residual stress at parent metal, which is also suggested by the various researchers. Next thing is that residual stress in welded joint 5356 has low value in comparison to the welded joint of 4043. So from the above conclusion and analysis, we suggested that the weld joint formed with the help of 5356 filler wire yields better properties than the weld joint which has been welded by filler wire 4043. These are the references I have taken. And that's thank you all of you.
Thank you, sir. That was a very good presentation.